Alright, let's see here. When I did the examples of the explanation actually of division using scientific notation, and you can look that up on YouTube, just look for division in scientific notation. There were roughly six lessons there. There were 6 lessons. I mentioned I might think about trying to give you an example of dimensional analysis in scientific notation. And I also mentioned maybe using something like the light year or the universe, size of the universe expressed in miles and millimeters. I figured I would do it. If you're going to study anything that involves, at the college level, engineering, chemistry, physics, any of the disciplines that require things like chemistry, like nursing, anything like that, you're going to need astronomy, especially. You're going to thermodynamics. This is big time important for both thermo and chemistry. You should really have a good grasp of things like scientific notation and especially dimensional analysis, and that comes in very, very handy. So I'm going to try to explain that via this example of looking at light year expressed in miles and in millimeters. Alright, what is a light year? It is the distance light travels in 1 year. And light travels at approximately 186,000 miles in a second, or per second. The problem is we're going to try to convert that notation, light year, right up here rather, right there, light year, into so many miles and ultimately into millimeters. So as you do dimensional analysis, what we're talking about here is using the units of things like miles and millimeters and seconds and meters and on and on and on, days and years. We're using those almost as algebraic elements, and we're going to treat them as such. We're going to start canceling them out, and there's really no way to learn this but just to jump ugly on it and get started. If we're thinking about 186,000 miles per second, notice how it's written almost as it is a division problem. 186,000 miles per second. That's light traveling in miles, and we're trying to figure out how long it will travel in years. So we're going from here to here. This is tricky business. There's kind of a knack to it. Some people take to it very naturally, and some people don't. In my case, I wrote this entire sheet here offhand. I've done it a lot, and I just have a natural knack for it. I guess it's kind of like juggling, you know. Some people take to it naturally, and some people just don't. So, in any event, 186,000 miles per second, and somehow I'm going to try to figure out miles in a light year. Okay, notice the second is in the denominator here, and I'm going to multiply by 1. 60 seconds divided by 1 minute is 1. And you'll just have to see how this plays out and get a feel for it. This is a touchy-feely kind of math, and chemistry and physics and astronomy, so you just have to kind of work your way out of it. You see this a lot in cooking too. You have to start converting teaspoons to gallons and gallons to teaspoons, and then you start talking about, you know, cc's and millimeters and all the other stuff, and nursing and all that. So you're going to see it all over the place. Wherever you have dimensions and you have to start switching between dimensions, you're going to have to get into this stuff. 186,000 miles per second. I'm going to multiply that by 1. Notice also that I'm going to start changing the form of things, but you will continually see that I'm changing only the form but not its value. So this is going to be, I'm going to multiply by 1, which is 60 seconds divided by 1 minute. That's okay. And here we go. Dimensional analysis. the seconds are going to cancel. This seconds down here in denominator will cancel out these seconds up here in the numerator. But I'm just multiplying by 1. Now I'm also going to multiply this 60 minutes over 1 hour. That is again a 1. But the minutes, again, the minutes in the numerator will cancel the minutes in the denominator, and so forth. Multiply by 1, 24 hours in 1 day, but the hours here will cancel these hours. I know this is awkward, but there's no way to get this except for practice. You have a starting point in miles, and you're trying to figure out in year, and you're just going to have to sort of jump your way through it. So finally, I'm going to say 365 days equals 1 year, so this is a form of 1. And notice I did not say 365.25. I'm not getting fussy about this. This is approximation. But anyway, 365 days does equal 1 year, and these days right here cancel this day right here. Days in numerator, days in denominator. They cancel out. So what we're left with is actually 186,000 times 60 times 60 times 24 times 365. And you can grind that out. And when you do that, you'll notice the only units left, which is what I was shooting for to begin with, are miles and years. Everything else has been canceled. Here to here, here to here, here to here, here to here. And I am simply left with miles per year. So, turns out that light travels, and again, notice the tilde, that means it's approximate, about 5.865 trillion miles per year. And you can read this off, just as a reminder. These are your hundreds, your thousands, your millions, your billions, your trillions. So that's 5,865,696,000,000 miles per year. There we go. Or, using scientific notation, again, move your decimal place here, right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Call it 5.9 times 10 to the 12th power, because my decimal place moved to the left. So that's about approximately the tilde. 5.9 times 10 to the 12th, that's a 12 right there, by the way. 5.9 times 10 to the 12th miles per year. But that's a light year. Kind of see it there. Anyway, so that's so far so good, I hope. Excuse me. Allergies, sorry about that. But what about the millimeters? We need to convert miles to millimeters. And I'm going to start again with some sort of miles. I know that's my starting point. This is my millimeters. And I'm going to have to try to find a way to, again, using dimensional analysis, get the units themselves, things like miles, kilometers, meters, all that stuff to cancel itself out. And you basically have to almost stack the deck with the units to make it work. So this becomes 5.9 times 10 to the 12th miles. We arrived up here with that. We know that, again, here is 1.6 kilometers approximately equals 1 mile. And in this case, this numerator will cancel this denominator. The miles will cancel away. And so we start the process again with another form of multiplying by 1, knowing that the kilometers will cancel this way, from here to here. So 1,000 meters does equal 1 kilometer, so I'm multiplying just by 1 here. I'm not changing the value, I'm just changing its form. And so this kilometer cancels that, and the process repeats. You've got 1,000 millimeters is equivalent to 1 meter. This is a value of 1. So this meter right here will cancel that one right there. And what we're left with, if you do it properly, is we're left with just millimeters, which is what we wanted. And that's millimeters per light year, etc. But let's see what we've got. We've got 5.9 times 10 to the 12th times 1.6. There it is. Notice the units have been canceled away. Times 1,000, there to there. And times 1,000, there to there. And the millimeters are left over. And we know that's millimeters in a light year. So if we multiply this out, I've rewritten this in standard scientific notation because it makes life easier. All I have to do now is add up the powers of 10, 12 plus 3 plus 3. That gives us 10 to the 18th. Oh, and don't forget that 0. So I'm going to add in 0. So it's 12 plus 0 plus 3 is 15 plus 3 is 18. There's your 10 to the 18th power. And 5.9 times 1.6 is going to give you about 9.44. So that will give you 9.44 approximately, there's that tilde again, approximately 10 to the 18th millimeters in a light year. Or that's how far light will travel in a year. Or 5.9 times 10 to the 12th miles. So there you go. You can play with this and try to express that. What's that? 10 to the 9th, I believe, is a billion. So that's what, a billion? Is that right? Do I remember? I'll let you look that up as to how you would verbally express that. But it's going to be 10 to the 9th, I think, plus times 10 to the 9th, which would become 10 to the 18th. So that's probably 9.44 billion millimeters in a light year. So, but you can play with all that and work with it. And 10 to the 12th, I know off the top of my head, is a trillion, so it's about 5.9 trillion miles in a year. But you can work with that and play with it and get it straight. I always, as I've told you in previous videos, I always mess up the verbiage, so I'll let you worry about the vocals. But that's a quick rundown on dimensional analysis and scientific notation. And I wish I could give you some hard and fast rule as how I know. As I said, I did this on the cuff, on the fly. How I know what units to use and how things cancel, it just is a knack that comes with time. In the big picture, dimensional analysis is huge in things like thermodynamics and chemistry, where you're getting into some really ghastly, really hairy equations. And there are times you get lost. And the only thing you can do is say, well, I've got a starting point here in dimensions. I need a starting point over here in dimensions. What do I keep multiplying by in forms of 1 to get me from the starting point to the ending point? I kid you not. This is very, very, very common, extremely common in things like thermodynamics, where the equations are so ugly and so nasty that you can't keep track of everything. You really need to say, okay, I've got a starting point in my dimensions here, let's say miles per second. I need, so many days or years or whatever. And I need to just basically jump from, one form to another, changing the form but not the value. You'll see as you take things like thermodynamics and chemistry, you will see this. This is important. It's just one of those little tips and knacks that you're going to have to develop, or those classes are going to be even worse than they are, and they're pretty ugly to begin with. So there you go. We'll see you next time, but there you go. Example of dimensional analysis and scientific notation using light year expressed in miles and millimeters. And, oh, by the way, I did check this. I checked it on the web. Somebody ground this number out in meters, and it came out 10 to the 15th. So I think I have corroboration on this number, so I'm pretty sure about this. I'm very sure about this. So I think the math is all okay. But sorry about that. Just bumped the camera. But you want to play with this and mess around with it and see what you get. So, all right. Until next time. There you go. Catch you. Bye.